Hi guys. We are getting ready to talk about the unit circle. This will be done in a very casual way. I do not want to do too much work with the unit circle prior to the activity that we will be doing in class. The thing to remember though about a unit circle is that it has a radius of 1 unit. It is important to note that we just say 1 unit. We don't specify if it is 1 inch or 1 yard or 1 centimeter. It is 1 unit long. That's all that matters for the unit circle. Having a radius of 1 unit. What we do with the unit circle is we place the center of that circle at the origin of a coordinate plane. So we can place it at 0, 0 on the coordinate plane. Since it has a radius of 1, where we would normally start reading an angle, we have a coordinate of 1, 0, right here at a 3 o'clock hand. Since it has a radius of 1 unit, as that radius goes open more and more, we can go up to a maximum height of 1. We can go to a minimum of -1. We can go down to a minimum height of -1. And then we can come back. We have been talking about angle measurement on a circle. If you pick any angle on the unit circle, you can use the coordinates of a unit circle to find any of the 6 trigonometric functions. So the next thing that we need to discuss is how to define trig functions on a unit circle. For any given angle t or value of t, if you consider that xy is a point on the unit circle, you can find the sine of that angle by reading the y coordinate. You can find the cosine of that angle by reading the x coordinate. You can extend that even more. We do know that the tangent is equal to sine over cosine, so the tangent of the angle would be equal to the y coordinate divided by the x coordinate, as long as the x is not equal to 0. These are our basic 3 trig functions, but we also have their reciprocal functions. Please write out reciprocal. This is a term that a lot of students want to call inverse, and that would not be correct. These are the reciprocal functions. Cosecant is the reciprocal of sine, so the definition on a unit circle would be the 1 over y. It would be the reciprocal of your y coordinate, as long as y is not equal to 0. To find the secant of that angle t, since the secant is the reciprocal of cosine, as long as we know the x coordinate, we can find the reciprocal of x, and that gives us the secant of t. And cotangent of t is the reciprocal of the tangent, so the ratio of x over y, as long as y is not equal to 0, will give us our cotangent. Before we look at an example, something really important for a unit circle. We have limitations to the possible y values. Since the radius is equal to 1 unit, we have a maximum height of 1 and a minimum height of -1. Well, remember that the y coordinate represents sine. This is the same as saying that -1 is less than or equal to sine of t, which is less than or equal to 1. You might recall this from before, but our sine values are enclosed between -1 and 1. Well, we also saw that the x-coordinate is equal to the cosine of t. So this is the same as saying that -1 is less than or equal to cosine of t, which is less than or equal to 1. So now we have a limitation to cosine as well. It is enclosed between -1 and 1. Let's just look at a quick example. We do know that 90 degrees angle would be located right here. So if I wanted to use the definitions of trigonometric functions for 90 degrees, then I can find the sine of 90 degrees, which is equivalent to pi over 2, simply by reading the y-coordinate of that point. The y-coordinate is 1. If I want to find the cosine of pi over 2, I can do that by reading the x-coordinate. My x-coordinate is 0. If I want to find the tangent of pi over 2, that would be equal to y over x, which is 1 over 0. Uh-oh, we are not allowed to have 0 in the denominator. That means that tangent for 90 degrees is undefined. Let's go ahead and write out all 6. To find the cosecant of 90 degree, which is pi over 2, we're really looking for the reciprocal of y. So we have 1 over 1. That is still equal to 1. If we want to find the secant of pi over 2, then this will be the reciprocal of x, which is 1 over 0. Uh-oh, we cannot have 0 in the denominator. That means that the secant is also undefined. And lastly, if we want to find the cotangent of pi over 2, then we have the ratio of x over y, that is the ratio of 0 over 1, which is equal to 0. We use the unit circle, that one coordinate, to find the 6 trigonometric functions of 90 degrees or pi over 2. Okay, so for the next example, or actually the next definition, it is the definition of a periodic function. Any function is called periodic whenever there exists a positive real number that can be added inside of the function, and the function has the same value as it did originally. The least number of that value that can be added is what we call the period of the function. Really, we're asking ourselves, when will those values start repeating? Well, since we just looked at the 90 degree trig functions, let me redraw that angle. 90 degree is right around here. The coterminal angles of pi over 2 will end up at the same place, which means that if I try to read the x and y coordinates of -3 pi over 2, or I try to read the coordinates of 5 pi over 2, they will be the same. That means that my sine and cosine will be repeated whenever I go around the circle. If I went around the circle, let's say 1 time, 2 times, and then another 3/4 of a time in a negative direction, I still end up in the same place. This angle, which is -720 degrees minus another 270 degrees, the angle that I have very flimsy drawn on here is equal to -990 degrees, but it has the very same coordinates as my 90 degree. So if I try to find the sine of negative 990, this will be equivalent to the sine of 90 degrees. It turns out that all of our trig functions are periodic. The period is not necessarily the same for sine and cosine, but we will get into that a little bit more. Actually, sine and cosine are the same, but they're not the same all the way around the trig functions. So tangent would have a different period than sine does. The next thing that I want you guys to very briefly look at, I do not want you to look it up or try to fill in all the values from here, as we will be doing an activity in class. But we will be trying to fill in the unit circle. For this unit circle, please remember that the radius has 1 unit length. That means that, remember, it is placed on a coordinate plane. So the coordinate on the starting point is x of 1 unit, and the height is 0. Well, what happens as you go up here? Now you're at the center, so you have an x-coordinate of 0, and then you have a height of 1. What happens is you move to the 180 degrees. You are at negative 1, height 0. As you scroll down, let me do that. So as you go down, you have a x-coordinate of 0, and then the height is at negative 1. On a unit circle, we want to fill in some of our special angles. Those special angles would be 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and then we're going to go by the same sections. So what I would like for you to do is try to fill in the degrees. If you have 0, 30, 45, 60, 90, what is the next degree that will come on here? What is the next one? What is the next one? So with the pencil, I want you to try to fill in all the degrees. And then I want you to try and think of the pies. When we talk about pies, we will be recording those in radians. Let's just go by pi over 2's. We start at 0 radians. I want to go by the 90 degrees. Well, I do know that a full half circle is equal to pi radians. My pi radians are equivalent to that half a circle. If I want to do the 90 degree, this is half of that semicircle, so it's pi over 2. So look at what happens here. We have 0, pi over 2's, then you have pi over 2, then you have 2 pi over 2, which simplifies to pi, and then you have another pi over 2, so that gives you 3 pi over 2. You can do that for the 30, 45, or 60 degrees also. It's easy to see that the 45 degrees is half of the pi over 2 angle. Well, half of pi over 2 is pi over 4. So now I can start counting in pi over 4 terms. 1 pi over 4, 2 pi over 4, which simplifies to pi over 2. Then I have 3 pi over 4. The next one is 4 pi over 4, but that simplifies to pi. The next one is 5 pi over 4. Note that I am only visiting those angles that actually split the 90 degrees in half. 5 pi over 4, another pi over 4 gets me to 6 pi over 4, which simplifies. Then we have 7 pi over 4. And then we would have 8 pi over 4, which simplifies to 2 pi. Other than that, I want you to attempt the 30 degrees. So start with the 30 degree and then count up to fill the rest of them up. If you're struggling with this, it's okay. We will be doing an activity in class that will finish it. See you tomorrow.